The formula that I gave you for this one said you're going to put x minus the values that go in here. The values that go in here are the target value, the average, the goal. Those are all the keywords that go right there. And then we're going to have a symbol that goes right here, and then we're going to have another number. So I am going to highlight the average. So that's telling me what the number that goes right here. The average number of seeds is 25. So I'm going to write 25. Whoops. I'm going to write 25 inside the absolute value bars. It says, what is the minimum maximum number? So they just want those endpoints. So that's going to be an equal sign. And vary, there's my other keyword right there. It can vary by 3. So since it can vary by 3, the 3 is the number that goes right there. So that's the equation. The absolute value of x minus 25 is equal to 3. It's isolated. I've written it, and the absolute value bars are isolated, so I don't have to do step 1. Step 2 is to separate. So I have x minus 25 equal negative 3 and x minus 25 equal positive 3. Solving it now involves adding 25 to both sides of both equations. So the solution to this one is x equals 22, and this one looks like it's going to be x equals 28. So what's the maximum number of seeds? Your minimum number to your maximum number. Your minimum number is 22. The maximum number is 28. And if this were on a graph, we would have a dot at 22, and we would have a dot at 28. All right, so I tried to color code this to maybe help you see that f of negative 3 is going to be on all of these graphs, and I'm going to do that in pink. So when I see f of negative 3, that means I'm plugging in negative 3 is my x value. So I'm going to go to negative 3 on the x-axis. Here I am at negative 3 on the x-axis, and now I'm going to travel up to my graph, and I'm going to pay attention to the y value. So the y value right there is 5. So f of negative 3 is equal to 5. F of negative 3, there's negative 3. There's my y value. That's at negative 1. So f of negative 3 is equal to negative 1. Here, f of negative 3, go to negative 3 on the x-axis. There it is. There's the y value. The y value is positive 1. And f of negative 3 is equal to, go to negative 3 on the x-axis, go up to my graph, and find the y value. I'm going to do the same thing for f of negative 1. Go to negative 1 on the x-axis, and then go to your graph. Well, it may look like that I have 2 different places to go. You may say, oh, I can go down here and be on my graph, or I can go up here and be on my graph. If you have 2 things to choose from, one's a filled circle and one's an open circle, always go to the filled circle. So I am going to go up here and pay attention to that y value. Where am I on the y-axis? I'm at 3. So f of negative 1 is 3. F of negative 1 here, negative 1, go to the filled value. That looks like it's at negative 3. Go to negative 1. That's right there. So that's negative 1. And f at negative 1, go to the filled value. That's also at negative 1. There's the y value. And then f of 2. Go to 2 on the x-axis. Here's 2 on the x-axis. Go to the dot on your graph, and then tell me what the y value is. So f of 2 is negative 1. F of 2 is, here's f of 2, here's my graph, there's my y value, -1. F of 2, here I am at 2 on the x-axis. I'm going to go up to my dot that's on my line on my graph, and I'm paying attention to the y value. That y value looks like it's 5. And then f of 2. Here's 2 on the x-axis. Where's my graph? There's my graph right there. And it looks like it's at -6. The next thing we're going to do is pay attention to the domain and range. I've kind of ran out of room, but I think I can write over here on the side. Domain for this one, if you move from left to right and pay attention to where it starts and where it stops. You'll see on the left right here, it starts with an arrow. So anytime it starts with an arrow on the left side, that means we're actually starting at -infinity. And we get right here to where there's a gap. But since those bars line up, our domain continues to go. As we move to the right along our x-axis, we get to another arrow, so that means the domain is all real numbers. This domain is going to be all real numbers. This domain is going to be all real numbers, and this domain is going to be all real numbers. So the domain for all of those are all real numbers, and why? Because we've got an arrow on the left, we've got an arrow on the right. Is there a reason why I might not get all real numbers? Yes, I will show you what that is. If I can find my mouse. So I went and made a graph for you that does not have a domain of all real numbers. You see, as I start moving over here, as I move from left to right, I do notice that I have an arrow first, but then I come to this stopping point, and this stopping point right here does not, nowhere either above or below that is there the other branch that starts. So I literally have a blank space right here in between -1 and +1. There are no x values in between -1 and +1. So the domain for this function would actually be in two pieces. It would start at -infinity, but then it would stop at -1, and it would be a bracket because of my field and circle. Then I would have to union that with a parentheses because there's no dot. It starts back at +1, and then as we move to the right, we see that there's an arrow. So we do have a gap in between -1 and +1 for that domain. Okay, let's do range. Let me see if I can get range a different color. We'll do range in purple. And the range, we pay attention to the range by going from the bottom up. So the first y value that we come into contact with is this y value right here. It's -4, and it's an open circle. And so we have y values until we get, well, you may think right here, but remember, this is an arrow. So even though we don't see that the graph goes on, we know that this graph goes on, okay? But if we keep sliding up, the other branch picks up right here at +3, but then the other branch stops at 5. So is 5 really the highest y value? Nope, because over here, this graph just keeps going up. So where my range does have a starting point, my starting point looks like it's starting at -4. It's an open circle, so that's why I put a parentheses. That arrow does continue to go up forever, so we're going to say the range starts at -4 and it goes towards infinity. This range has an arrow pointing down. That's the, it may happen about the same time that does, but remember this arrow right here is continuing to go on down right here. So if we were, going from the bottom up, we would see this arrow a long time before we would see that. And then we've got this arrow going in this direction. So the range of this one would actually be -infinity to +infinity. The range of this one, same thing. You've got this arrow going down forever. You got this arrow going up forever. So it's also -infinity to +infinity. And this one is different. We've got arrows going down on both ends. So that means that the range is definitely starting at negative infinity. And negative infinity is negative infinity. It doesn't matter whether it's this side or this side. They're both going to be down there forever. But as we move to the top, we do have a highest point. And that highest point happens right there. And the y value right there is 1. And since this is a solid graph, it's not a dotted graph, we are going to include that in our range. So this one has a highest value of 1. Let's go ahead and do the range of this one. The range of this one, if we're moving from bottom up, there it starts right there. That's the first time we see a y value, and that y value is at -3. It is an open circle. We have y values here. We have y values here. So it looks they're both going up to positive infinity. So the range is going to go on, continue on to positive infinity, but it started at -3.